Welcome back. Today we're going to be taking a look at aggregate functions using Oracle SQL so we can find some more information out about databases. Let's go ahead and take a look at that. When we're talking about aggregate functions, we need to look at what they actually are. So an aggregate function is a function, instead of operating a single individual cell, operates an entire column's worth of data. So we're grabbing an entire column's worth of information at a time and calculating information based on that. Now, of course, the column type has to be able to fit the function itself. So I can totally minimize a data or text for alphabetic earliest in the dictionary, or finding the earliest date value of that, but I can't average a text or a date value because there's not an average date or an average text value that we can look at that. So as you look at the sample data right here, you can see that the birth year 1990, 2010, 1979, definitely can find the min, the max, or the average of any of those. We can even sum them up if we really wanted to. I don't know why, but we can. For our ID column, we can totally do anything we want with that because it was all numeric values with the exception of null, and so we'll just exclude that value from that. With last name, I can only find a max or a min on this because FG, DFG, VDV, blah, 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 is only going to be just a bunch of keyboard mash, and I can only find the earliest value or the latest value with that. But we do need to make sure when we're keeping in mind that the idea of the minimum value is not the shortest thing what we're looking at on that. What we're looking at on the idea of min value we're talking about text is the idea of the earliest in the dictionary. And remember that capital letters come before the lowercase letters because of the joys of ASCII/Unicode. So keep that in mind. Now, what functions are we looking at? Well, we've got 5. We have count, average, min, max, and sum. Count is pretty self-explanatory. It's the number of rows that match. Average is the mean average numeric value. Min is the smallest, max is the largest, and sum, of course, is totaling all those values inside that column. Pretty easy to work with. Now, how do we do this? So all the aggregate functions take a single parameter and return a single value. So we have coalescing into a single square for all the stuff that's inside that. Average, min, max, and sum each take the column name as the parameter and return the calculated result from that column itself. Count, however, is a little bit different. Count only takes asterisk as its parameter because I want to get all of the stuff for that. And so it's the only thing that's going to get for that. Now, just by itself, if you just do count as the only value inside your select query, you're just going to get the number of rows in the database, or in that table, excuse me. However, when we add a new clause, the group by clause, we get some really good information. We get how many of each of those different groups are inside that. So we can actually count things up and do some great organization and actually get real information that we humans can use to do some cool stuff. So let's go ahead and take a look at that. Those two new extra clauses are group by and having. So a group by clause is required. You have to have this if you have more than simply aggregate function calls, which is most of the time. Your columns, of course, in your group by are going to be separated by commas, just like they are inside the select clause or the order by clause. Extra columns, if you add that, however, will invalidate your results. And so what I really recommend is that you just follow the same exact order that you had inside your select clause, so you can make sure you got this one, then this one, then this one, then this one, making sure you do that properly. So it's a great way to keep track of that. We do write the group by clause after the from and where clauses, where if present, but it executes before the select clause. So keep that in mind that we're always writing this in that order right there, but it executes before the select, which is up on the top. The next clause we have is the having clause. It is optional because, again, just like with the where clause, you don't have to restrict the number of rows. Sometimes it's just enough to actually do that query. We write this after the group by clause, and it executes before the select clause as well. So again, we have the idea that our group by and having clauses, although they're written at the very end after our from and our where, group by, then having, these are executed before the select at the very top because, again, the written order does not actually match the execution order. So keep that in mind when you're working with your database queries. So when do we talk about this? So if we have more columns than aggregate functions called them, the group by clause is going to execute after the from, of course, and the where clauses, but before the select, because we're going to figure out, oh, I've got to put these piles together. So that's what, again, the group by clause is doing, is it's putting the piles together that the aggregate function needs so it can actually work on those operations. The having clause executes again after the idea of the group by, but now before the select still as well, because it now has to, you have the coalesced results, and it can do the functions based on that, like, oh, I have this coalesced results of group information, and I can do operations based on that as well. So again, we have to have the group by happen first, and then we can do the having because we have the groups we can operate on for that having clause itself. Execution order, we're going to start off with the from. That's the first step we have, where we pick the table and we get to join, so that's where the tables plural come into play. We haven't covered that yet. Then we have our where clause, where we limit the results based on the values itself. Our group by is how I put those groups together. I coalesce values around those groups that we specify in the select clause. Then we have our having clause, where we're going to limit the results based on those aggregate functions. And then finally, we actually select the columns we're working with. So again, we have to have that group by identified in advance before we even get to the select clause itself. So that's, again, why we want to follow that same order, because it makes sure we always keep track of those right pieces. So we'll take a look at the actual execution order of sample query right here. We have select section ID count as enroll count from enrollment, grouping by section ID, having a count of asterisk greater than 4, ordering by count, and then section ID. So the select clause is executed fourth, but first we have from, then group by, then having, back up to select for step 4, and then back down to order by for step 5 to actually go through and look at the actual execution order of that query. So again, the select clause, although it's written first, executes almost last every single time. So keep that in mind. Here we have a demo query. You can see what's going to happen with that. So we have select section ID from enrollment. And as you can see right here in the results, we get 226 rows selected. So if you just do section ID from enrollment, we have 226 rows. We have all those things. However, when I add a distinct to that, I've got 64 distinct values in there. And so we have the select distinct section ID from enrollment. So we can see, I've got 64 distinct values. And so, okay, that's cool. Why do I only have 64 values in there? Well, this is where I can use the idea of the count function and group by to actually understand the information that's contained inside that previous distinct value. So by using the aggregate query right here, we have section ID count as enroll count from enrollment, grouping by the section ID. And so the enrollment count, I can see that there are 100 in section ID 4 and 48. There's 5 students. However, in 149, there's only 1 student. And so those 64 rows that I have selected, it's the same 64, but now I know the why on that because the count tells me, there are 8 in 156 and 5 in 155, but there's only 1 in 149. So I can see why there are 64 different rows out of the 226 actual values that were originally there inside the original query. So I can use the idea of an aggregate function to get real information that I can use as a human to understand the data that's inside the table. I hope this is a helpful way to introduce aggregate functions. Cheers, we'll see you next time and have a good day. Bye-bye.